Welcome to this explainer. Have you ever felt like you're just feeding facts to a brick wall? Or maybe you've struggled yourself to really lock a complex new idea into your brain? Well, today, we're diving into a framework that absolutely flips the script on how we grasp and teach complex concepts. Let's get right into it.
Picture this classic classroom scene. A teacher stands at the front and drops a seemingly simple question. Children, what does the word democracy mean? Now imagine the typical response. It's almost always one of two extremes, right? Either absolute, painfully uncomfortable silence or a robotic, perfectly memorized recital straight out of a textbook. And honestly, neither of those tells us if the learner actually gets it. So let's contrast the stark limitations of simply reciting definitions with the rich, deep comprehension that comes from genuine understanding. When we just memorize words, it's like information is sitting on a fragile surface, easily blown away or forgotten the second the test is over. But true conceptual understanding, that's like planting a deep, sturdy root system. The big question is, how do we systematically guide learners from that shallow memorization to that deep-rooted understanding? To bridge that massive gap, we turn to a brilliant tool called the Frayer Model. Now, this isn't just some vague educational philosophy. It's a highly practical graphic organizer explicitly designed to help learners wrap their heads around a concept deeply. Think of it as a structural solution. It literally stops us from asking that flat, one-dimensional question, what is it? And instead forces us to really dissect and interrogate a concept from multiple angles. The core of this model is beautifully simple. Right in the absolute center goes our target concept. Then, surrounding it are four distinct quadrants: definition, characteristics, examples, and non-examples. By systematically breaking the concept down into these exact four boxes, we completely bypass those mental shortcuts and force a full 360-degree view of the idea. Let's actually walk through exactly how this works using our earlier example. Okay, so we start by defining our central word, democracy. Now, sure, a textbook might say something formal like government by the people, usually through elected representatives. But here is the absolutely crucial point. We do not want learners just copying that verbatim. No way. The real magic happens when they process that formal text and rewrite the meaning in their own words. That translation, that is the very first major step in taking cognitive ownership of an idea. From the definition, we slide right over to characteristics. And here, we aren't just looking for a basic meaning anymore. Nope, we are analyzing what special features or rules tell us that a system is indeed democratic. We're looking for the moving parts, things like people actually participate, leaders are elected, citizens have protected rights, and decisions follow established rules. Being able to pinpoint these features proves they understand the actual mechanics of the concept. Next up, we anchor this abstract, floating concept squarely to reality through examples. This is exactly where learners get to connect the dots to what they already know. By identifying relatable, real-world instances, whether that's big national elections or even highly localized things like voting for their own class representatives, they pull the concept right out of the clouds and into their everyday lives. It proves they can spot the concept out in the wild. Now, this final quadrant might honestly be the most powerful part of the entire model: non-examples. We flip the script and ask, what would absolutely not be an example of democracy? Well, we might look at scenarios like a monarch making every single decision single-handedly, or maybe a classroom where students have zero opportunity to express their views. Establishing these contrasting boundaries is incredibly powerful, because honestly, you don't truly know what something is until you can spot exactly what it isn't. Let's see this in action with a completely different subject. Taking a word like mammal in science really highlights the versatility of this framework. Suddenly, a learner isn't just blindly memorizing a science term. They are actively defining that it gives birth and milk. They're characterizing it as warm-blooded with fur. They're tossing out examples like a dog or a cow, and they are fiercely contrasting it with non-examples like a fish or a frog. They are actively classifying, comparing, and justifying the whole way through. By organizing information this way, the sheer power of the model becomes so clear. We're facilitating deep understanding, critical thinking, lively discussion, and pristine concept clarity. We fundamentally shift the cognitive load. Instead of the brain burning all its fuel just trying to remember a random string of meaningless facts, it uses that exact same energy to foster critical thinking. It literally becomes an active learning engine rather than just a passive storage drive. All right, I want to break the fourth wall for a second and challenge you directly. Yep, it's your turn. I want you to take just 30 seconds and mentally map out those four Frayer quadrants for the word inference. Go ahead. How would you define it in your own words? What are its key characteristics? Give me a solid example. And crucially, give me a clear non-example. Really think about it.
Okay, let's see how your mental map compares to ours. Notice how the definition focuses strictly on reaching a conclusion via evidence. The main characteristic? It requires clues. And for examples, noticing someone walking in with a wet umbrella implies that it's probably raining outside. But look closely at the non-example. Just saying it's raining without looking outside or having any evidence whatsoever. Did you come up with something similar? Pretty interesting, right? What makes this tool so genuinely remarkable is its widespread adaptability. It is definitely not just a language arts strategy meant only for vocabulary lists. It is a powerful engine for conceptual learning across all subjects. You can use it in science for tricky concepts like habitats, in social science for dissecting the Constitution, or even in mathematics for finally grasping what prime numbers or fractions truly are. Because at the end of the day, concepts are concepts, no matter the subject.
When we step back and look at the big picture, we can clearly see how this model builds a procedural staircase of cognitive development. Remember, understand, analyze, apply, and finally explain. This perfectly aligns with the big goals of competency-based learning. The learner isn't just passively receiving information anymore, they are actively climbing these steps, building a robust, highly defensible understanding of the material that they can actually go out and apply.
As we wrap up this explainer, the absolute final takeaway I want to leave you with today is a bit of a provocative shift in questioning. From now on, don't ask only, what is it? Instead, ask, what does it mean? What makes it different? Can you give me an example? And what is not an example? So the ball is in your court. How will you use these 4 simple questions to move your learners, or honestly, even yourself, from rote memorization to truly meaningful understanding?